Welcome to Sundar's lecture. This is lecture number 2, and in this lecture we are going to see conversion of one radix to another radix. I will explain you a bit later. See this one. What is the topics? What are all the topics we have seen in the previous class? We have started with the review of number systems, and in that we have seen 4 different number systems, right? Binary, octal, decimal, and then hexadecimal. And we have started with the decimal. The base of decimal is 10, and how the decimal numbers are working. And then we have gone for binary, the base is 2. So we have seen how to convert the binary number into decimal number, and then we have seen octal number, the base is 8, and then we have seen how to convert the octal number into the decimal number, and then we have seen the hexadecimal, the base is 16, and how to convert this hexadecimal number into decimal number, right? So in this class we are going to see the conversion of one radix to another radix. We are going to see binary to octal, binary to hexadecimal, hexadecimal to binary, octal to binary, and then octal to hexadecimal. All those kind of things we will see today. Before that, I just want to explain you little things in binary numbers. See, what is the binary number? Binary, we know, right? So binary, the base of the binary is 2. Combination of zeros and 1. This is the binary value. We know that one. We have seen in the previous class. Now, what my question? See, this binary value works like, for example, it is equivalent to a decimal one. See, we have to understand whatever the number system, we have to understand it by the decimal values. Try to understand, because we humans know only the decimal values, right? So what you do, for example, you have a 2 power, I will write a formula now, I will explain you a bit later. 2 power n is equal to c, where n is equal to number of I generally call it as input, I always call it as input, or you can call it as digits, number of digits, or input or digits. I can digits. Maybe I will explain you. And C is the combination. C is the combination. Why I am writing this one? So that you can easily understand. If I say it is 2 input system, 3 input system, 4 input system, then you have to understand what is the number of combination. What is the number of combination? You will get it done. For example, if I am writing n is equal to 2, which means it is 2 input system. So what you will get? If n is equal to c 2, then what is the c value? What is the c value? N 2 power 2, which is equal to what? 4. So 4 number of combination. You will get 4 number of combination if you are going for 2 input system or 2 digit system. Anything you can get it by yourself, right? Digits are input. For example, if it is 2 input, then the value, it will be 2 digits. Only 0, start with 0 0, and you will have 4 number of combinations, right? What is the next value to 0? It will be 1. So it is 0 1. What is the next value of 1? I am just explaining you things with the decimal. 2. Can you put 0 2 here? No. Why? Because binary values will have only zeros and ones. So what is the next value? You cannot put 2, 3, 4, 5, 6, 7, 8, 9. You cannot put up to 9. What is the next value to that? It is 10. 10 is the combination of 0 and 1, right? So you can put 10. What is the other value? 11, right? What is the next value? It is 11. So it will be 11. And now what is the next value? Can you put 12, 13, 14, 15, 16? If you go until 99, you cannot put it down. What is the next value of 99? It is 100. If I put 100 here, it will be 3 digit. 3 input system. So you cannot put, because you have only 2 input system. So now you see here, for a 2 input system, you will have 4 number of combinations, that is 0 0, 0 1, 1 0, 1 1. This is the combination. This is nothing but the combination. Try to understand. This is the combination. So how many combinations are there? You have 4 combinations. So I will write, this is 0, this is 1, this is 2, this is 3. Try to understand, right? This is 4 number of combinations. Actually, this is the decimal number. This is the decimal value. Try to understand. Try to understand. This is nothing but the equivalent decimal value. If I put 0 0, then it represents 0. If I put 0 1, then it represents 1. If I put 1 0, then it represents 2. If I put 1 1, it represents 3. In decimal. In decimal. Try to understand. And I will tell you one by one. The next value. If I put n is equal to 3, then what is the combination of C? What will be C now? Huh? 2 power, I will substitute in this formula, 2 power 3, then it will be is equal to 8. 8 number of combinations you will have, right? You will have 8 combinations. 8 combinations. That is the whole idea. 8 combinations. And how it actually comes down, say I will put here, 3 means you try to start with the 0, 0, 0. 3 inputs, first 0, and then what is the next value? It is 1, so 0 0 1. What is the next value? It is 10, like this, 10, 0 1 0, next value 10, and what is the next value? It is 11, 0 1 1. So what is the next value? It will be 100. It will be 100. So 1 0 0. Next to, you cannot put 12 13 14 15. Everything will not be a combination of zeros and ones. And then 100 will be a combination of zeros and ones. And what is the next one? It is 1 0 1. Right? And then what is the next one? 1 0 1, 100, 101. And from 1 0 2 3 4 5 6 7 8 9, you cannot put it down. And the next value will be 1 1 0, 110. That is the next value. And then what is the next value? It is 111. 111. What is the next value? If you go for the next value, it will be 112, 113, 114, 115 until 999. You cannot see a number with the combination of only zeros and ones. And if I put 1000, it will be a 4 digit. So you have to stop here. How many combinations are there? See here. How many combinations are there? Combination is this one. And how many combinations are there? 1 2 3 4 5 6 7 8. You are getting 8. So you see here, if I put this one, this is 0, this is 1, this is 2, this is 3, this is 4, and then this is 5, this is 6, and then this is 7. And what is this one? What is this one? This is the equivalent decimal value. This is the equivalent decimal value. Try to understand. This is the equivalent decimal value. This is actually 0, 1, 2. If I put 3, then the equivalent binary value will be 11. It will be not 11, 0, 1, 1. 0, 1, 1. And if I say 5, then it will be 1, 0, 1. Even you see here, if I put 3, then it will be 1, 1. You see here, that will be also 0, 1, 1. 1, 1. Try to understand. Don't confuse yourself. That is why I am explaining you bit deep into this binary values, because we generally say, if I see any 7, you have to put 1 1 1. If I say 5, then you have to defaultly understand that it is 1 0 1 in binary value. These kind of things you have to be very clear before entering into the other things in the digital system design. You have to be very clear about these certain numbers. Up to 16 you have to remember. If you remember up to 16 decimal values, equivalent binary values, then it will be very easy, because we always use 4 input systems. 4 input system. This is actually 3 input system. This is 2 input system. This one 2 input system, and then this is 3 input system. This is 3 input system. And if it is 4 input system, that is very important. I will just write it down. So what is the formula? We know, right? 2 power n is equal to c. Now I am going for n is equal to 4. So what is this one? It is 4 input system. It is 4 input system. So what is the value now? It will be 2 power 4. What is 2 power 4? It will be 16. So combination will be, how many combinations will be there? It will be 16. Try to understand. So that is also very easy. You don't need to panic here. See here, 4 input, so it will be 0, 0, 0, 0. 4 inputs. What is the next value? You know, 0, 0, 0, 1. That is the first one. The next one, you know, 1, 0, 0, 1, 0, 10. And what is the next one? 0, 0, 1, 1, 11. And after 11, what you will get? 100. It will be 0, 1, 0, 0, 100. And after 100, what you will get? 101, 101. And after 101, what you will get? 110, 0, 1, 1, 0. And after 110, what you will get? It will be 111. See what I have told you? Up to 999, you will not get any combinations of only zeros and ones. And you will get 1000. 1, 0, 0, 0, 1000. And what is the next value? It is easy. 1, 0, 0, 1, 1000 and maybe 0, 0, 1, 1001. And what is the next value? 1, 0, 0, sorry, 1, 0, 0, 1, and then 1. This is 1, right? This is 1. And then what is the next value? It will be 10. 1, 0, 1, 0. That means 10. And then 1011. 1, 0, 1, 1. 1011. And what is the next value? 1100. 1, 1, 0, 0. And what is the next value? 1101. And what is the next value? 1100. And what is the next value? 1111. And if I go to the next value, then what is the next value? It will be 10000. Right, to understand. Right, how many number of combinations are there? Because I have to stop here, because I need only 4 combinations. I should not go for the 5th one. I should not go for the 5th combination. Right, to understand. That is why I have stopped here. And what is the here? And now you see here, I can put this value. This is the first combination. 0, 1, 2, 3, 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10, this is 11, this is 12, this is 13, this is 14, and this is 15. From 0 to 15. How many number of combinations are there? 16 number of combinations. 16 number of combinations. And what is this values? These are all decimal values. These are all decimal values, because the numbers we know whatever. If I say 14, then what is the equivalent of 14? It is 1110. If I say 5, 5 is always 101. 5 is always 101. See here it is 5101, and if you see here also it will be 101. But number of combinations, number of inputs, it will be different. And if I say 3, it is 11. Here also it is 11. And you see here also it will be 11. Try to understand. So if I say a 4-digit number, 4-digit inputs, then you will have 16 number of combinations. That means in combination, what is this one? 16 number of up to 16 decimal digits, decimal values, maybe not digits, decimal values. Like that you can say, right? Can you understand now? Now what we will do? We will write a 16 number of combination values for every octal, by hexadecimal, binary, whatever it may be, right? So you see here, I have just taken the tabular column, and I will write down this one now. See here, binary values, I will just write it down. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? This is the decimal values. From 16 number of decimal values I have written here. Now, binary values I have already written here. For 16, from 0 to 15 decimal, I have written the binary values. But every time you don't 0, 1, you don't remember like 0, 1, 10, 11, 100, 101. Maybe it is the actual procedure, but I will tell you the shortcut now. What you do, 16 number of combinations are there, right? So 16 values will come. So first you put 8 zeros. 0, 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then you put 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. This is a shortcut method. See, try to understand. I am putting like in a shortcut way, right? So 8 zeros, 8 ones, and you put 4 zeros now. 1, 2, 3, 4, and then 4 1. 1, 2, 3, 4. And then again 4 zeros. 1, 2, 3, 4. And then 4 1. 1, 2, 3, 4. And then you put 2 zeros now. 0, 1, 2, 2 1. 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2. And then you put 0 1. Alternate values. 1, 0, 0 1, 0 1, 0 1, 0 1, 0 1, 0 1, 0 1, 0 1. That's all. That's all you see here. The same thing, whatever we have got here, that is coming here. So this is a shortcut method to write the binary values, 16 combinations. Right? If you have 32 combinations, 2 power 5 will be 32. Then you put 16 zeros, 16 ones, 8 zeros, 8 ones, 4 zeros, 4 ones, 2 zeros, 2 ones, 0 1 0 1. Then you will have 5 digits. Try to understand. It is a shortcut method. It is a shortcut method. Then what is the octal value? Octal is very simple. It will be 0, 1, 2, 3, 4, 5, 6, and then 7. See, try to understand. It will use up to 7, and you should not go for 8 here. No, 8, 9 will not come down. Why? Because 8 and 9 doesn't comes under the octal values, because octal value will lies between 0 and 7 only 8 digits. So you will get what? 10 here. Next value will be 10 because it lies in 0 to 7. Then it will be 11, 12, 13, 14, 15, 16, 17. All values lies between zeros and 7. You have to be very careful, try to understand, right? What is the next one now? Hexadecimal. It will be easy because I have written you, I have told you already in the previous class. It will be 0, maybe this is a octal, and hexadecimal, it will be 16 numbers will be there. Defaultly you will have a 16 numbers. It will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is the equivalent value of 10? It is A, B, C, D, E, F. Right. This is the 4 input system. If we have 4 input system, then this is the binary value equivalent decimal values from 0 to 15. For 0 to 15 decimal numbers, the equivalent binary is this one, the equivalent octal value is this one, the equivalent hexadecimal value is this one. Right? Can you understand the difference between the decimal, binary, octal, and then hexadecimal? You have to write like this. You have three inputs, then it will be coming from 0 to 7. Then you will have like this. Only this value. This part will come. I will explain you. By practice, you can easily understand things, right? So we will see now conversion. First conversion. See, actually, the conversion, I will have 3 types of conversions. Maybe I will write by myself. See, you cannot see in any books like this, but myself, I always split the conversion into three types of conversions. Types of conversions. Try to understand. I will tell you now. See, first one, involving 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 binary. Involving binary. Try to understand. I will write like this, involving binary. Next one, any radix, any radix to decimal. This is the next type. And number 3, decimal to any radix. Any radix. This is the 3 different types of conversions from one number system to the other number systems. See, decimal is a separate procedure. See, you have any radix from binary, octal, hexadecimal to decimal, and then from decimal to binary, octal, and then hexadecimal. You have a different procedure. This is a different procedure. 3 different procedures you will have, and then that is why I have split the conversion into 3 types. First, what we will do, involving, we will take this one, involving binary, involve, in this one, involving binary. So, in involving binary, what we are going to see, the first one, binary to octal, binary to octal. That is what we are going to see now. What is the base of binary? The base of binary, it is 2. What is the base of octal? It is 8. Try to understand. How 2 becomes 8 now? How 2 becomes 8? It will be 2 power 3 will be is equal to 8. Will be is equal to 8. Right? So, now you have to understand this 3. That is very important. That is very important. See here. For example, if they have given you like we are going to convert the binary value to the equivalent octal value, to the equivalent octal value, right? So what I am going to do now, we will take an example now. First one, you have a combination like this. For example, 1 0 0 1 0 1 0 1 1 point 1, maybe point I will tell you bit later. 2, that is the base 2 will be is equal to what is the equivalent octal number. You have to convert the binary value into octal now. You need to understand this one. So what you do, if they have given you a questions like this, you know, right, the combination 2 power 3 will be is equal to 8. So what you do now, you just write the question 1 0 0 1 0 1 0 1 1. This is the values. You have to split the binaries into 3 digits. 3 digits from the rightmost side. From the rightmost side. See this one, 1, first digit, second digit, third digit. Put a line here, put a line here, put a line here, and then 1, 2, 3. You have to split 3 digits. 3 digits, because we know if binary the base is 2 and the octal the base is 8. So how 2 becomes 8? By the combination of 3. So I am splitting it by 3. Right? Now I have split it down. Now I have split it. Right? This is the value. So what you do now? You have to see what is 0 1 1. See here in the combination of 3 we have seen, right? What is 0 1 1? I have already told you it is 3. It is 3. Right? You put 3 here, 3, and what is 101? What is 101? What is 101? It is 5. It is 5, right? This is nothing but 5. And what is 100? What is 100? It is 4. So you put 4 here. That's all. We have converted. This 453 is nothing but 45453 is nothing but the octal value. So the answer is 1 0 0 1 0 1 0 1 1 at the base of 2 which is equivalent to 453 at the base of 8. See why I am seeing this one, why I am seeing this combination, because for an octal number you will have the combination from 0 to 7, from 0 to 7, right? Equivalent binary is here. The equivalent binary is here. That is what. See, I've written it as decimal. Anyhow, this is a decimal. But in octal also, you have only 0 to 7. See, try to understand. You don't confuse. You will get this point if you practice one by one. So this is the procedure. This is the procedure. For example, if I have a point like this and value, I will just write it the second problem. If I have a 1011000001 0.1010 base 8, and what is the sorry, not base 8, base 2, and what is the equivalent of base 8 value for this one, for this one. Then what you do, you have to write all the values again, same like 1 0 1 1 0 0 0 1 0 1 point 1 0 1 0. So if you have any decimal point like this, if you have any point like this, then what you have to do, you have to split, right? So from here you have to split three numbers, because this is the procedure to convert binary value into the uh, octal value, right? So what you have to do here, you have to split. You don't see this one, come here from point, from the rightmost bit. What you have to do, you have to put a line after three digits, 1 2 3. You put a line, you put a line, and then 1 2 3, you put a line, and then 1 2 3, you put a line here. See here, if any numbers coming like this, what you do, you add two zeros. You add two zeros, right? So that is the procedure. You have two zeros, so that it will have three digits, and then from here, from point here, you have to go like this, 1 2 3, put a line, and you see there is only one 0. What you do, you add another 2 0. That's all, right? So this one, you have to make this one. So this is point, and you have to write what is 101. What is 101? It is 5. I will write straight away now, because I don't need to go again here, so that it will be 5. No, you have to defaultly understand. So it will be 5. What is 000? It is 0. What is 011? It is 3. What is 001? It is 1. And then what is 101? Again it is 5. What is 000? It is 0. So the final answer, it will be 1305.50 at the base of 8. At the base of 8. Now we have converted this, for this binary value, the equivalent octal value is this one, right? Can you understand? This is how we need to convert binary to octal. And then we will see now binary to hexadecimal, and I will explain you in the next class. We will continue in the next class. So what are all the topics we have seen in today? See, we have started lecture number 2 with the conversion of the radix to the another. But before that, we have seen the basics of binary. So we have seen input system, 2 input system, 3 input system, and equivalent decimal values, and then 4 input system and then equivalent decimal values, and we have made a tabular column here. So 16 decimal values, and then for those 16 decimal numbers, we have converted the equivalent binary numbers, octal numbers, and then hexadecimal numbers. And then we have gone for types of conversion. There are 3 types of conversion involving binary, any radix to decimal, decimal to any radix, and involving binary, we have gone for binary to octal number. And we know binary is 2 and then octal is 3, and then combination will comes by 3, this 3, right? And then we have converted the binary value to the octal value. That is the procedure we have seen. So we will wind up today. We will see in the next class. Thank you.